Now that we have discussed about the parallel lines and the transversal which make various properties in mathematics, the alternate angles, the corresponding angles, the interior angles, the exterior angles, and vertically opposite angles. Let's take the topic connected to the parallel lines. Parallel lines connected to the same line. So here today's session is about the lines which are parallel to the same line. Today's session is about the property which relates to the lines which are parallel to the same common line. Let's see how the two lines are connected if they are parallel to the same line. So imagine I have the common line, say line L. If there are two lines which are parallel to L, say for example there is a line L1 which is parallel to L, and say there's another line L2 which is also parallel to L. So here my condition is, let L be the line. Now let L1 be parallel to L, and there exists another line L2 which is also equally parallel to L. Now the relation between the lines L1 being parallel to L and L2 being parallel to L makes us the mathematical property with the common line L that the other two lines must be parallel. If there are two lines such that they are parallel to the common line L, then obviously the two lines also must be parallel to each other, is how we understand the property connected with lines parallel to the same line. Therefore, if there are two lines which are parallel, that implies L1 must be parallel to each other, is how we connect the property related to the parallel lines in common line L. So here we have two lines which are parallel to the same line, are parallel to each other, is how we understand the property connecting two lines which are parallel to the same line are parallel to each other. The lines L1 and L2 which are parallel to line L are in turn parallel to each other, is how the property connects with lines parallel to the same line L. Mathematically true for all lines in such situations. Now that we have discussed all the properties of parallel lines geometrically connected in a plane, let's see the applications of parallel lines in real life. The topic of the session is applications of parallel lines in real life. Applications of parallel lines. So let's see the different applications of parallel lines in real life. Imagine I have the condition of two parallel lines with certain angles given. I can find certain unknown angles using the properties as we have learned in the previous sessions, connecting two parallel lines and transversal. So let's see how we can use the learned properties into the session as an example real life problem. For example, I have the question which says find the remaining angles for the following diagram. So in this case, I have two lines. Say there are two lines L1 and L2 which are parallel to each other. And say I have a transversal which is given in the problem. Now with the given lines L1 and L2 and the transversal which cuts the lines L1 and L2 at two distinct points out here and out here, let me say I have an angle out here which is given to be 110. Now my question is find the remaining angles for the following diagram. So given that this is 110, I need to find this angle, this angle, this angle, this, and this using the 110 degrees. So let's see how we can find each of the angles, this, and this using 110 degrees which is given out here. So let's see each of the angles. As we know that the angles are represented by angle 1, angle 2, angle 3, angle 4, 5, 6, 7 and 8. So let's represent each of the angles by 1, 2, 3, 4, 5, 6, 7, 8. And let's find each of the angles, angle 2, angle 3, 4, etc. till angle 8 using the first angle which is given to be 110 degrees. So here it is given angle 1 is equal to 110 degrees. Clearly angle 1 is given to be 110 degrees. Given that angle 1 is 110 degrees, let's find first angle 2. So initially to find angle 2. So we know that clearly angle 1 plus angle 2 is 180 degrees because this makes a straight line. Therefore, angle 1 plus angle 2 makes a straight line that is 180 degrees. Therefore, this plus this is 180. That implies angle 1 which is 110 degrees is substituted for angle 1 out here plus angle 2 which I need to find using this equation. Therefore, when I find angle 2, this is 180 minus 110, which on further simplification gives angle 2 which is 70 degrees. Therefore, my angle 2 utilizing angle 1 which is given to be 110 degrees is used with straight line property and I get angle 2 which is 70 degrees. Is how I get this angle to be 70 degrees. Now let's find angle 3. Let's see how we can find the next coming angle, that is angle 3 out here. To find angle 3, so here to find angle 3. So to find angle 3, clearly I see angle 1 and angle 3 to be vertically opposite angles. Therefore, from the diagram I see that angle 1 equals angle 3 since they are vertically opposite angles. They are vertically opposite angles and hence they must be equal, is what we have seen as the property in the previous session. Vertically opposite angles are always equal. Therefore, angle 1 equals angle 3. But we know that angle 1 is 110 degrees as clearly given in the condition in the given problem, angle 1 is 110 equals angle 3. Therefore, I clearly have my angle 3 which is equal to 110 degrees. So my angle 3 is now 110 degrees. Now comes finding angle 4. Let's see how we can find angle 4 using the basic angle 1 equals 110 degrees. Next, to find angle 4. As we can clearly see, just like in the previous session, that angle 1 and angle 3 are vertically opposite angles. Similarly, angle 2 and angle 4 are also vertically opposite angles. Therefore, I have angle 2 equals angle 4, since they are vertically opposite to each other. Vertically opposite angles, and vertically opposite angles are always equal. Therefore, let's see what is angle 2, which we have already found in the previous case. We have found angle 2 to be 70 degrees, which I'm going to substitute in place of this, which I get through angle 4. Therefore, this being 70 degrees, indirectly I get my angle 4, which equals 70 degrees. That's how I understand the concept of finding angle 4. So my angle 4 out here is 70 degrees. So each of the angle in the first part of the line L1 and the transversal are now found out. Like angle 1 given as 110 degrees, angle 2 which is found to be 70 degrees, angle 3 which is found to be 110 degrees, and angle 4 which is found to be 70 degrees is how we find all the 4 angles of the line L1 with the transversal. Now comes the next question on how to find angle 5, 6, 7 and 8, the angles made by the line L2 with the transversal, is what is the next investigation to be continued with. Now that we have found these 4 angles, let's see how we can connect this set of the 4 angles with this set of the 4 angles. So let's start with initially angle 4. As clearly we found angle 1 which is 110 degrees, now the question comes on finding angle 5. So let's see how we can find the next consecutive angle, angle 5. Now clearly I see that angle 1 and angle 5 are corresponding angles, and hence 1 and 5 must be equal, because corresponding angles are equal when 2 lines are parallel. I have my angle 1 which is equal to angle 5 because they are corresponding angles. Since corresponding angles, and they must be equal as the property we have seen. Now these two being corresponding angles and are equal, again I have my angle 1 which is already known to be 110 degrees, and therefore substituting for this, I have this to be 110 degrees which is equal to angle 5. Therefore my angle 5 is 110 degrees. Angle 5 is now found to be 110 degrees is how we get angle 5. Next, let's see how we can find angle 6. The next question is about finding angle 6. Angle 6 is what we're going to find next. To find angle 6. Now clearly I can see that angle phi and angle 6 form a straight line angle, just like angle 1 and angle 2 which form a straight line angle. So I have angle phi plus angle 6 which is clearly equal to 180 degrees, since they form a straight line. They form a straight line. Therefore, phi plus 6 equals 180. Now, we know angle phi is 110, which I'm going to substitute here for this. 110 plus 6 is 180. That implies my angle 6 is 180 minus 110, which comes to the right. That implies angle 6 is 70. 180 minus 10, which is 70. Therefore, angle 6, which is 70 degrees, is what we have found using the straight line property, utilizing angle phi. Next is about finding angle 7. So let's see how we can find angle 7 using the properties. To find angle 7, as we can see clearly that 5 and 7 are vertically opposite angles. So let's see if they are equal. Obviously, because vertically opposite angles are equal. Or also we can say 3 and 7 are corresponding angles. So you can either utilize angle phi equals to angle 7 or angle 3 equals angle 7, because 7 acts as vertically opposite angle for phi and 7 also acts as corresponding angle for 3. So let me take the concept of corresponding angle to find angle 7. Now, since 3 and 7 are corresponding angles, angle 3 must be equal to angle 7, since they form corresponding angles. They form corresponding angles. Therefore, angle 3, which is 110 degrees, therefore I substitute for angle 3, which is 110 degrees, equals angle 7, which is already known out in the previous case. So I get my angle 7 to be 110 degrees. This is how I find angle 7 using the corresponding angle. Also, this can be verified for vertically opposite angle, because the angle 7 which I have obtained is nothing but the same as vertically opposite angle phi, which is 110. So vertically opposite angles are equal and corresponding angles are equal, can be verified through the values of the angles as obtained. 110, 110, 110, 110. This is how we can cross check on the equality of the respective angles. Angle 7 equals 110 degrees. Next is about finding the last angle, angle 8. Let's see how to find the last angle of the parallel lines. To find the last angle, angle 8. Angle 8 is vertically opposite to angle 6. Angle 8 is corresponding to angle 4. It's our choice to take either the vertically opposite or the corresponding. So I take angle 8, 6 equals angle 8, because since they form vertically opposite angles. Since they form vertically opposite angles, they must be equal. And my angle 6, which is 70 degrees, is substituted out here, which is already found in the previous case. Therefore, this being equal to this, now my angle 8 is 70 degrees. The last angle out here is found to be 70 degrees. Therefore, I have each of the angles which I can find through the given question, which says find the remaining angles for the diagram given out here. This diagram has only one angle which is given, that is angle 1 is 110. Now I have all the remaining angles. Angle 2 which is found to be 70 degrees, angle 3 which is found to be 110 degrees, angle 4 is 70, angle 5 is 110, angle 6 is 70, angle 7 is 110, angle 8 is finally 70 degrees. Is how we can find the remaining angles of the parallel lines connected with the transversal, strictly using the properties what we have learnt in the previous sessions, connecting with corresponding angles, vertically opposite angles, alternate angles, interior angles, and exterior angles. Real life applications of parallel lines in daily life situations. Now that we have discussed about the parallel lines, the next concept which comes is about connecting the angles in a triangle where all the sides are non-parallel or they intersect each other. So let's see the property connecting the three lines which intersect and form a triangle. As we know that today's topic is about angle sum of a triangle. What is a triangle? A triangle is a three-sided closed figure. As we can see, the three sides are the three straight lines which intersect at three distinct points. Imagine I have three lines which intersect at points A, B and C. Obviously, the line AB is not parallel to line BC, and line BC is not parallel to line CA, and line CA is not parallel to line AB. Is how we understand the three lines which intersect to form a triangle. Now let's see what is the angle sum in a triangle. There is a property which connects all the three angles in a triangle. As we can see, this is angle A, this is angle B, and this is angle C. And mathematics connects these three angles with angle sum in a triangle. Let's see what is the sum of all the three angles in this triangle. So my angle sum property says angle sum property says that in triangle ABC, the angle A, which is denoted by this angle A, and the second angle, angle B, which is out here, angle B, and the third angle, which is out here, plus angle C, must be equal to 180 degrees. Is how we connect with angle sum property. Angle sum property defines in a triangle ABC the sum of all angles in a triangle is 180. So this is read as sum of all three angles in a triangle is always Sum of all three angles in a triangle is always 180 degrees. Sum equals 180 degrees is how we understand the angle sum in a triangle. Now that we have discussed about the angle sum in a triangle, that is, the sum of all the angles in a triangle is equals to 180, let's see the definition of interior and exterior angles in a triangle. A triangle has different types of angles, and let's see in brief about the classification of angles in a triangle. As we see here, here is a triangle. I can clearly extend these lines out here. Then clearly I see that there are different types of angles which I have, say this, this and this. Let me denote by 1, 2 and 3. The triangle A, B and C. Now, as can be clearly seen here, if each of the sides are extended on each of the sides of the triangle, I have the other set of angles which we have out here. So these angles also play a vital role in defining certain properties in the branch of mathematics, especially in the properties related to triangles. So this being extended forms another angle, and here this side being extended forms the other angle, and this side being extended forms the other angle. Let's see how we can connect the properties. Now here we define interior and exterior angles in a triangle. Interior and exterior angles in a triangle. So I have 1, 2, 3 which are interior, and I have 3 exterior angles out here which are 4, 5 and 6. Because they are outside the triangle, angles 4, 5, 6 are said to be exterior, and 1, 2, 3 are inside the triangle. So angle 1, angle 2 and angle 3 are called interior angles. So interior angles are those angles which are inside the triangle, and exterior angles are those angles which are outside the triangle. Is how we understand the triangle concept related to angles, interior and exterior angles. So here interior angles are defined as angles inside within the triangle, and in this case angle 1, 2, 3 are interior. In this case angle 1, angle 2, angle 3 are interior, is how we understand interior angles. Similarly, exterior angles are the angles outside the triangle. So these are called exterior angles because 4, 5, 6 are outside the triangle, and 1, 2, 3 are called interior angles because they are inside the triangle. Angles inside the triangle, interior angles. Angles outside the triangle, exterior angles, is how we understand the concept. Now that we have defined about interior and exterior angles in triangle, let's see the exterior angle property which connects the interior angles in a triangle. This session is about exterior angle property in a triangle. Exterior angle property in a triangle. So let's see the property in brief. Imagine I have a triangle A, B and C. Now here let me take one of the side and extend it so that I take the side BC and extend this side further. Now clearly when I extend one of the side, I get one exterior angle. So this is my exterior angle which I identify. And these are the interior angles, and clearly we know that angle A, angle B, angle C are interior angles in the triangle ABC. So with this interior angles, also I identify that angle A and angle B are interior opposite to exterior. Because these are opposite to the exterior, therefore A and B are interiorly opposite angles. This being opposite to these. Also, angle A comma angle B are interior opposite angles to this exterior angle. And this angle AC, if I extend this to be D, my ACD angle is exterior angle. My angle ACD is exterior angle, and angle A and angle B are interior opposite angles to this exterior angle, angle ACD. So angle A, angle B are specially interior opposite angles to the exterior angle ACD. Is how we understand the geometrical concept of each of the properties. Now comes the exterior angle property in a triangle. So as we have the exterior angle and interior opposite angles, the mathematical property which defines exterior angle property is exterior angle property. Exterior angle is equal to sum of interior opposite angles. So if I take this to be 1, 2, 3 and 4, that implies my exterior angle, which is angle 4, must be equal to sum of interior opposite angles 1 and 2. 3 is not interior opposite, but 3 is an interior angle. Exclusively opposite of angle 4 is angle 1 and angle 2. Therefore, exterior angle equals sum of interior opposite angles is what is called exterior angle property in a triangle, which states exterior angle equals sum of interior opposite angles. Now that we have discussed about exterior angle property in a triangle, let's see how we can apply this for the given problems. This session is about applications of exterior angle property. Applications. Imagine I take a problem which has a triangle ABC, which is produced out here. Then I have this to be (140) and this to be 30 or 60. Now my question is about finding this angle B or even this. So here my question says find the remaining angles in the triangle ABC. So here is the triangle ABC in which I had to find the remaining angles, that is angle B and angle A. So let's see how we can connect exterior angle property to this problem. Now clearly angle C is given to be 60 degrees and the exterior angle at A is given to be 140 degrees. So assuming this to be exterior angle, now I try to identify the interior opposite angles. This being the exterior angle, its interior opposite angles are this and this, as clearly can be seen. So angle B, angle C are interior opposite angles, and my exterior angle out here is BAD, which is 140 degrees. BAD, which is 140 degrees. Now this being 140, let's see how we can use the property. Clearly we know that the exterior angle property says from exterior angle property, exterior angle equals sum of interior opposite angles, being angle B and angle C, is how we get exterior angle property. Now this exterior angle being equal to 140 degrees as given in the problem, I substitute this with 140 degrees, which is equal to angle B, which we need to find, plus angle C as clearly given to be 60 degrees out here. Therefore in place of angle C I substitute 60 degrees, which on further simplification gives angle B is 140 minus 60, which on further subtraction 140 minus 60 is 80 degrees. Therefore my angle B is found to be 80 degrees. So the angle B using exterior angle property is 80 degrees. Now the question is how to find angle A. As we know the two angles in a triangle, the third angle is 180 minus sum of, using angle sum property. So let's see how to find angle A using angle B equals 80 and angle C equals 60. Now here using angle sum property, angle A plus angle B plus angle C is 180 degrees in this triangle ABC because of angle sum property. Angle sum property is what we get. Now using this, substituting the values of B and C, I get this as angle A plus angle B, which is 80 degrees, plus angle C, which is 60 degrees. Equals 180. That implies angle A is 180 minus 80 plus 60, which on further simplification gives 180 minus 140. That implies angle A is 40 degrees. And now I have my angle A, which is 40 degrees. Therefore, my each angle of triangle is angle A equals 40 degrees as found here, and angle B, which is 80 degrees, which is found using exterior angle property of this, and then angle C, which is 60 degrees given. Using the properties of triangle, we can find the possible angles in a triangle. Is how we connect with applications of exterior angle property and angle sum property in the triangle.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.